Cystine kidney stones are the rarest and one of the most nasty kidney stone types out there. But what makes them so unique? And if you're one of the unfortunate few that does suffer from this stone type, what can you do to slow down formation or even stop them completely? If you'd like answers to these questions and more, stay tuned for this video. Hi, I'm Joey Weichman, and welcome to Stone Relief. In today's video, we're going to start the process of diving into the rarest kidney stone type. And when I say that we're going to start diving into, what we're really talking about is the condition that is behind this stone type, which is cystinuria. We'll cover the stone types in another video. So in this video, we'll get into the background behind this condition that causes cystine stones, what the process of stone formation actually looks like, and the things that you can do to entirely slow down stone formation or stop it completely. So let's begin with some background on the condition. So cystinuria is a rare inherited genetic disorder, meaning this is something that is going to be coming from some sort of a familial aspect. This is really truly the genetic kidney stone type. All the other types that are out there, there is some like ancestral type of connection to this, which is at least my hypothesis. However, they're mostly due to diet, like inappropriate diet choices that lead to the stone formation. Whereas this is truly driven in genetics. There is a condition that you have that is causing this. So it's super rare. Chances are that you're already aware of it if you're forming this, because only about 1 in 7,000 people worldwide form this. And about in the US, it's about 1 in 10,000. So super, super rare. Now, the other piece of this puzzle is that it's mostly men, and they really don't understand the sex-driven characteristics behind this, but over the course of the population and all the different people that have been polled, it's being more prevalent in men, to a factor about 2 times the men that it impacts than women. Now, cystinuria is a defect in your body's ability to transport amino acids. And the amino acids these are building blocks of protein. So it's nothing to fear. Like, it is present in almost every single thing that you consume on a day-to-day basis. However, this particular issue causes some problems. Now, the amino acid that we're after in this particular condition is cysteine. But there are other amino acids that could be potentially impacted by this transport disorder. However, what happens with this particular instance with this amino acid cysteine is we end up in a supersaturation condition. So if you're familiar with our videos on calcium oxalate kidney stones, these stone types require supersaturation. And what this means is that there are an excess of elements that are no longer being able to be dissolved in a liquid solution. In this situation, it is urine is the solution that we're talking about. So there's too much cysteine floating around in the kidney, and we'll get into this in the next chapter in more detail. So it supersaturates, meaning that is a whole bunch of it that is undissolved, that is free to bind together and start to crystallize to form these kidney stone types. So supersaturation, yet again, strikes as an issue. Now, this particular condition is detected through urinalysis. So then there are a whole host of other ways to do this, but I think the urinalysis is probably the most cost-effective and the most, the easiest to obtain. Now, in that urinalysis, what they're looking for is cysteine levels that are being excreted through your urine. And again, this is a snapshot in time, typically a 24-hour urine scan. This is not a perpetual, this is what you are. This is a snapshot in time. And typically for a normal, healthy adult, we're looking at less than 30 milligrams of cysteine being present in the urine on a daily basis. Where we start to get into trouble is when we start to see over 250 milligrams of cysteine, and this is a signal that cystinuria could be potentially a problem here. Now, over 250, that doesn't seem like that big of a jump between 30 and 250, but some individuals who have this, they can produce multiple hundreds, if not close to 1,000 milligrams of cysteine, depending upon what they're eating, on a given daily basis. So this starts to become a problem big time. Now, another thing that you can use as kind of a very easy, simple telltale sign is if your urine smells like sulfur or like that rotten egg type of smell that you get with when you hard boil eggs, there could potentially be a problem here with transport of amino acids that could be pointing to cystinuria if you form kidney stones. But what are the actual mechanisms by which these stones form? Stay tuned for the next chapter and we'll dig into that in more detail. Okay, so welcome back. Now that we know what levels of cysteine presence in our urine can be problematic for cystinuria and cystine kidney stone formations, what's the mechanism by which this is actually happening? So, at a baseline, cysteine levels need to be greater than 250 milligrams on a daily basis. This is kind of the foundational elements that we need. Next, your urine needs to be acidic. And when I say acidic, I mean a pH of less than 7. So cystine stones actually dissolve the more alkaline your urine gets. Now there is a caveat to this, so I don't want you running off going like, I gotta alkalize my urine. Like there is a limit to that, because then if you go too far, you set yourself up for another stone type, which we'll cover in the last chapter. So just know, your goal is to really neutralize your urine. Between 7 and 7.5 is a safe zone to be operating in, because again, cystine stones start to dissolve in pHs that are above 7. You might be asking yourself, well, how is this possible? Well, really, this has to do with cystine solubility. So cystine solubility, meaning the ability for it to be dissolved in a liquid solution, goes up as your urine pH increases. And again, I want to just say a cautionary note, up until a certain point, because you start to have problems with other stone types when you go too far. But the example is this from the research. So in a solution with a pH of 7, roughly 250 milligrams per liter of liquid solution can get dissolved. And this ramps up pretty quickly, because in this next example we see a pH of 7.5, and that almost doubles, actually did double in our example here, but doubles the amount of cystine that can be dissolved in a particular solution. So the more alkaline your urine gets, to a certain extent, the more that these type of stones and the stone-forming elements that make them up, which is cysteine and amino acid, start to dissolve and dissipate, and they lose their ability to crystallize and form kidney stones. Now, again, as I was mentioning, as a cautionary note, pHs above 7.5 when it comes to urine increases your risk dramatically for calcium phosphate stones, because calcium phosphate, when those two things are mingling around in your kidney, an alkaline urine solution of 7.5 or greater really sparks crystallization and increases that. So calcium is going to favor phosphorus, calcium phosphate or phosphate, versus oxalate, which it typically prefers, I guess, in a more acidic type of solution. So you can go too far with this, so don't go crazy. The goal is urine neutralization. So how do all these mechanisms work though? So you know we mentioned supersaturation over here in the first chapter about stuff that leads to the point for when crystallization can occur. So this is a very very crude representation of what is happening with like the inside of the kidney basically. So over here you've got this barrier that's the urine, and then over here you've got the blood, and like in the middle here is really kind of like where the tubules and the nephrons of the kidneys, all the actions of the actual kidney itself filtering your blood is occurring. So in a normal healthy individual over here on this side here, we have cystine, which is represented by these little hexagonal shapes. They're kind of coming and going between the urine and the blood, which is normal. This is meant to be able to keep things in your body in balance. This is a normal process. And these little things right here are kind of the transporters, if you will, that shuffle cystine and other amino acids back and forth between these two areas. Now, in an individual that is broken, who has cystinuria, who has a transport issue, again, very, very crude here, but you can see here, there's not any cystine that's being reabsorbed back in the blood, which means that all these little hexagonal shapes here, you know, we had just a couple hanging around over here in the normal individual, are now starting to pile up in the actual urine or your kidney, and that's causing a problem. It says when you have a buildup of cystine inside of your urine in your kidney, this is where we reach that supersaturation point, and when supersaturation occurs, given time, these molecules start to bind together. They start to kind of glom on top of themselves on the sulfur molecule, and they start to crystallize, and then they start to grow, and they can be relatively problematic. So really everything that we're dealing with here deals with broken transporters of the amino acids being able to get back, reabsorbed back into the bloodstream in order to maintain a balance that your system is meant to maintain on a regular basis. And when it's broken, we get kidney stones. In the next chapter, we'll talk about some of the things that you can do to try to minimize or slow down stone formation and maybe even prevent it.
Just a reminder, this information is available in written form on our website. Find the link below in the description.
All right, so in this last chapter, we're going to talk about some wild stuff. Now, I say that it's wild because my hypothesis around all the things that I've learned from cystine stones kind of flies in the face of most advice that people are receiving from Western medicine in terms of how to manage this. So we're going to kind of build through the foundation here, the different things that are probably more common sense for people, and then we're going to get into some of the stuff that may fly right in the face again of what has been recommended to you by your doctor or your urologist. Now, At the very baseline, as with most kidney stone types, proper hydration is absolutely critical. And we're really shooting for a minimum of 3 liters a day. And we got a video on the best way to manage or strategize drinking this much water. If you want to check it out, we'll link it up in the cards. But this level of water consumption is going to be able to provide you with a baseline ability to urinate that is going to be sufficient enough to reduce what I call as the windows of supersaturation, meaning you're going to be passing urine frequently, so frequently that you're limiting the ability for cystine to pile up in your kidney. And again, in the last chapter we looked at, when it starts to pile up as a result of the breakdown of that transport, those stones start to form. So if we can prevent supersaturation from occurring by being properly hydrated, this is a major win for people who are forming cystine stones, which are very, very challenging to eliminate, if not stop completely. But this can be a very, very big positive lever that you can pull on to be able to slow down or maybe even stop cystine stone formation. Next, urine neutralization. So, as we talked about in the last chapter, these stones cannot form in neutral urine. Neutral or alkaline urine. But again, there's an extent that you can go too far with that. So rewind if you're not really sure what we're talking about when we're talking about urine neutralization. But this will slow things down. You want to use like a urine pH test strip maybe on a daily basis to be able to assess where you're at. Because again, these are just snapshots in time. They're not test once and it's the way it is throughout your entire day. It doesn't work that way. So you test as often as you can to be able to understand where your urine is. But if you neutralize your urine pH, these stones won't form, because the more towards alkaline you go, the more ability your body has to absorb cystine. And then if it's absorbed, that means there's less of it to be able to crystallize inside your kidney. So this is a good thing. Next, there are thiol-based drugs. Now, this is a pharmaceutical type of remedy that I generally tend to stray away from because of all the side effects that are associated with it. But in essence, the way that these work is these kind of work like citrate with calcium oxalate stones, except instead of binding with the oxalate, these thiol-based drugs bind with the cysteine amino acid and then eliminate the ability of these amino acid molecules, the cysteine molecules in particular, to be able to bind together. Very similarly with the way that calcium oxalate and calcium phosphate stones work, but if you can eliminate the amount of raw materials that are in the system, you slow down, potentially even stop crystallization of that particular stone. And then lastly, where things are going to get a little bit wild and controversial, it's talking about dietary changes. Now, for most individuals that I've come across in the last decade that I've been doing this, their doctor or their urologist and or both have recommended they completely stay away from animal proteins, to like maybe just the extent where your body will get just a little bit of protein, or maybe they're even suggesting getting it from plant protein, which is not the same. So stick with me here and let's walk through the rationale. So an animal-based or a carnivore diet is a urine neutralizer, meaning if you eat that way consistently, on an average basis, your urine should be somewhere between that 6.5 to 7.5 on the urine pH scale. This is just what's typically been found. Now, there are things that you could do that would lend it one way or the other if you're not following it closely, but if you follow closely, you're going to end up right in the middle, which is where humans should operate on a normal basis. Now, the other sides of these coins. So if we're right in the middle with an animal-based or a carnivore diet, what happens if we eat the standard American diet? Now, standard American diet, which is very heavy on processed foods and seed oils and just kind of like crap. This is a urine acidifying type of diet. And this is why we see a lot of calcium oxalate kidney stones here in the US and a lot of uric acid kidney stones, because most of the population is metabolically unhealthy, leading to some sort of metabolic dysfunction, which is then going to acidify their urine. So standard American diet, Western diets are acidifiers. And then we've got the vegan or the vegetarian diets on the other hand. And this is where most doctors and urologists are going to put people who have cystinuria, because they go, well, if we can alkalize the urine, we can slow down cystine stone formation. And they're correct, but in a vacuum only, because what they fail to realize is that the more alkaline your urine goes, the more you set yourself up for calcium phosphate kidney stones. So eating a vegan or a vegetarian diet will, yes, alkalize your urine. However, you have to be super careful, because if you're eating a strict vegan or vegetarian diet, more often than not, your pH is going to be over 7.5. If you form kidney stones, you're probably going to be forming calcium phosphate kidney stones. So you need to be careful with this. But again, if you're part of the population that forms kidney stones, an animal-based or a carnivore diet is really the direction that you're going to want to go, because not only will eliminate some of these stone-forming elements for other stone types, but in the case of a cystine stone, it will neutralize your urine, thus slowing down or even stopping formation of cystine kidney stones. Are you spending thousands of hours of surgery just to end up with another kidney stone a year later? Learn everything you need to know to say a big you to your kidney stones inside our free community at kidneystones.com.